Hello, welcome to today's video lesson where we will solve a strong base, strong acid titration problem. I do find that these problems can be difficult and there's a lot of steps in the problem solving, so hopefully this video will help you with some clarity on how to approach a problem like this. So let's say we have 5 milliliters of 0.20 mole per liter NaOH, and we titrate that into acid of the same concentration of 25 milliliters. After you do this titration, what is the pH of that solution? So to solve the question, what I did is I wrote down the chemical equation first. So again, we're adding NaOH to HCl. So we do have to write the equation. And I'm going to set up a BCA table. So BCA stands for before, change, and after. And this is actually a little bit similar to an icebox, especially if you've been practicing acid-base equilibrium problems. And the before component, what I want to do is compare the quantity of HCl and NaOH to each other. So compare how much do I have. And in chemistry, we always compare in terms of mole. So I have a mole formula that I'm going to use. Moles equals concentration times volume. Okay, so let's start with the HCl. The HCl's concentration, it's 0.20 mole per liter. Its volume is 25 ml. So we do have to change milliliters to liters so that my units cancel out properly and the math works. So that'll be 0.25 liters. We're going to cancel out the liters and we're left with a mole value of 0.005 moles of HCl. So that's great. Let's also compare and figure out how much sodium hydroxide, how much base I have. So let's convert that into mole. So mole equals concentration times volume. The base's concentration is also 0.20 moles per liter. I have 5 milliliters of it that I'm titrating in. So again, we're going to change that to liters. It's 0.005 liters. Liters will cancel out. And I've got a mole value here of 0.001. Okay, let's think about this for a second. Okay, let's visualize. So in the titration, you have a burette. This is usually where you find the base. And underneath the burette is a receiving flask of, in this case, HCl. Okay, now in this titration, in this part of the titration, you've only titrated 5 milliliters of NaOH into 25 milliliters of HCl. So what we can, and we can also tell by the moles, what we can tell is that the HCl is excess. You have remaining acid left over, and actually all of the base will get consumed as it will be my limiting reactant. So we're going to show that in our BCA chart under the concept or under the component of change. Now change is pretty much showing how these reactants consume one another. Now, another way you can tell which one is limiting is by doing like a ratio calculation or a cycles calculation, but this is a 1-to-1 mole ratio, so I'm just going to kind of eyeball it. I see that there's less NaOH, so it is my limiting reactant in this reaction. As a result, all of it will get consumed by the acid. So I'm going to say minus 0.001 to show that the acid consumes all of the base. And I'll show that again here under the NaOH, showing that all of it gets consumed. So after these mix, so after this titration occurs and these things mix into the flask, I'm going to have an excess amount of 0.004 moles of acid or HCl. Now I'm going to have a amount of 0 mole of NaOH. Remember, this was my limiting reactant, right? So all of it is consumed. I'm left with 0 of it in this flask after this first part of my titration. Now, in regular stoichiometry, I'm usually concerned with the limiting reactant to tell the quantity of products, but in a titration problem where I'm asked to find the pH, I really want to know what's excess. So what's excess in the flask, that's going to help me solve my pH value. So with that being said, let's take our excess reactant, which is HCl, and actually rewrite it as an excess equation. I'll do it as a Bronsted-Lowry. So HCl plus water produces hydronium, H3O, H3O plus, and Cl minus. So why am I doing that? Well, again, I'm being asked to solve for the pH. And as we can see, the formula for pH, it's the negative log of the hydronium concentration. So I really want to know how much of this do I have in my flask, so in this excess component. Well, what I do know is that I've got a mole value of 0.004 moles of HCl. Because it's a 1-to-1 ratio with the hydronium, I have the same amount of hydronium. HCl is a strong acid, remember, so it will produce full of hydroniums. And that's great. I have moles, but I need to know concentration. So to get concentration, I also need to know the volume of my solution. So at this point in the titration, I had 25 milliliters of acid in the flask. I titrated 5 milliliters of base. So I actually have a total volume here of 30.0 ml. Okay, so let's convert this now into concentration, which is moles divided by volume. So that will be 0.004 divided by my total volume. I have to change it to liters though, because concentration is expressed in moles per liter. This will give me 0.133333 repeated moles per liter of hydronium. So that's how much of this ion I have. So let's take the pH by taking the negative log of my hydronium concentration. Okay, so this will equal, pH is negative log of 0.1333 repeated moles per liter, and that will give me a pH value of 0.88. This is my final answer for this problem. And it does make sense because it reflects your excess acid. And if you were to look at this on a titration curve, you've barely started the titration, right? So if you actually think about a titration curve problem or a titration graph, we've got pH versus volume of NaOH added. So, when you have 0 milliliters of base added, the pH will be obviously something acidic depending on what acid it is, also depending on what concentration it is. And then my strong acid, strong base titration curve, it looks like this. It's like an S shape, right? So after 5 milliliters of base was added, let's say around here, again, I've barely started the titration. And so it reflects this still very acidic pH value to show that that acid is still very excess until you reach that equivalence point or endpoint of your titration. So let me know if you have any questions about this concept. I do find that titrations can be tricky. There's a lot of steps and different things that you could be asked of. But if you did find this video helpful, it would be so great if you could like and subscribe. And if you have any questions, please let me know in the comments. Thank you very much and have a great day.